Hello everyone, let's solve a very interesting problem today. In this problem, we are given two strings and the characters at the same index are considered as equivalent characters. For example, at index 0, we have these two characters for a given words, so we have to group them together. Similarly, for our next index, we have these two characters, so we'll form a separate group for them. Similarly, for our next index, we'll group these two characters. And now when we go to the next character, we see that one of the characters already belongs to an existing group. So we'll add this pair of characters to our existing group. Similarly, for our next pair of characters, we'll form a separate group. And again, we see that one of the characters belongs to an existing group. So we'll make it part of the same group. So after going through all the pairs of characters, these are the 4 independent groups that we'll have. In our problem, we are also given a base string. And for each character in it, we have to find which group it belongs to, and then we'll have to map it with the lexicographically smallest character in that group. For example, character P belongs to our first group. The smallest character in that group is M, so we'll map our original character to M. Similarly, our next character A belongs to the second group, and A is the smallest character in that group, so we'll map it with A. Similarly, our next character belongs to the third group and K is the smallest character in that group, so we'll map it to K. We'll do the same thing for the remaining characters and this will be our answer. And if there's a character in the base string that does not belong to any group, in that case we can consider it to form a self group and it will map to itself. Let's try to come up with an intuitive solution for this. Let's see what happens when we encounter these two characters in our strings. The first thing that we'll do is to group them together. Since they are grouped, so any of these two characters, if they are in our base string, we'll have to map it to the smallest character in this group. So if we encounter M or N in our base string, we'll have to map it to M. Similarly, when we encounter these two characters, we'll have to form a separate group for them. The smallest character in this group is P, so for either P or Q in our base string, we'll map it to P. Now let's see what happens when we encounter these two characters. We see that the character N already belongs to the green group, so we'll add our other character to that group. Now A will become the smallest character in the group, so for any of these three characters, we'll map it to A. So we could also say that this group is represented by character A. Similarly, for these two characters, we'll update our red group and it will now be represented by character C. So we see that these characters in some way represent a hierarchy in which the smallest character in the group represents them. So when we encounter a pair of characters, we try to see if they fit into an existing group, and if the new character will be smaller than the head of the group, then it will represent the group. Now let's see what happens when we encounter two characters that belong to two different groups. So in this case, what makes sense is that we have to somehow merge these two groups into one. But the problem will be in determining which character will represent this group. Since A is the smaller character of these two, we'll represent all these characters in this group by A. So what we are doing in this problem is that we are placing each character into a group, and when we have to merge two groups, we check both the head characters of the group, and whichever will be smaller will represent the combined group. So this problem can be solved using a very common graph algorithm called as union find. This can be used to solve many problems where there's a group involved, and these groups have a hierarchy so that each element in the group can be represented by the parent of the group. And when we have to merge two different groups together, we find the parents of both these groups, and based on some conditions, one of these parents will be represented by the other one. We'll implement two methods for this. The first method will be the find method, which returns the root of its group, and we'll implement the union method, which will merge the two groups by changing the parent of one of them to be represented by the other one. The time complexity of this would be the maximum of the string lengths of the base string or our input string, and since we have to maintain the hierarchy for only 26 characters, our space complexity would be constant. Let's create a hash map to store the parents of each character. Now let's define our find function, which returns the root of the group for a character. The first thing that we'll check is if that character does not belong to a group, Then we'll create a self group for that character, so it set its parent to itself. For each character, we have to traverse up the tree, going through each of its ancestors to find the root character. And for the root character, the parent will point to itself. So if that condition happens, we know that we have reached the root character. So for going up the tree, our current character will now point to the parent character. In our case, the chain length can at most be 26 characters. But if we had more elements in this chain, there's one path compression technique where we change the parent to the grandparent. So the next time this lookup happens, we'll be jumping many steps to reach the root faster. This can also be done recursively so that all the elements in the chain will now point to the root. Since we have changed the parent to the grandparent, our current character will now point to it. And once our current character becomes the root character, then we'll return it. Now we'll define our union function, which takes in two input characters. We'll now find the parents of these two characters, so we'll call the find function on each of them. If both the root characters are different, then we know that we have to merge these two groups. So if our first root character is greater than the second root character, since we have to take the smaller of these two to represent the whole group, we'll assign the second root character to represent the combined group. So we'll change the parent of our first root to point to the second root. Otherwise, we'll change the parent of the second root to point to the first root. Now we are done with both the union and find implementations. We'll now go through each pair of characters for both our input strings. We'll zip these two strings so that we can traverse without using the index. Since this pair of characters have to belong to the same group, we'll assign them to the same group using the union function. And once we have gone through all the pairs of characters, our union function would have merged all the similar groups together. Now let's define a variable to store our result string. Now we'll go through each character in our base string, and for each character we'll map it to the root character of the group it belongs to. To find the root, we'll call the find function for each character. At the end of this, we can return our result. Let's submit it. You can see our solution is accepted. If this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.